work, man, and stay flat, okay?
Okay, I'm a flat earther.
GE.
What's up, heathen? How y'all doing?
I'm good. I'm amazing, actually. We started off tonight with our lovely guest giving me a compliment and how hot I was. So it's a good start. Right, Chris?
Yeah, sure.
I was actually, full disclosure, I thought that's what he meant, but see, I have these charcoal wipes that I keep here right here. So if my face gets shiny, I can just, wipe my forehead. He came in when I was in the middle of doing that and said, "You look hot." I thought he meant hot as in my appearance, but he just meant stifling hot. So yeah. GE, I have to say, starting out, I love the tank top that you're wearing.
Oh, yeah? Yeah, you know why? Because it's, why you so bitch made.
Yeah, you can get yours at the in the non-sec shop at www.nonsexshow.com/merch, and ask everybody that you know why you so bitch made. I have to say, let's start out tonight by saying a very sincere and heartfelt thank you to all of you for supporting the channel. When I started NonSequitur last year, I had a number in mind of what I would be okay, or what I hope to hit, the number that I wanted to hit overall. And as long as I could hit this number, then I could be happy with, what we've done here. And today at around noon, we hit that number, and we hit 30K, and that's unbelievable. It's humbling, and I have to say thank you to Godless Engineer, and to Casey and Steve and Shannon and Katie for being a part of this show, and for being here with me and making sure that I have someone to walk through the darkness with me every night. It means more than you know. So since you're here, GE, thank you very much, buddy.
Oh, I'm sorry. Can you say that again?
I was saying thank you very much for everything that you do, for helping me hit that goal. It's people like you, Casey, Katie, Shannon, that really helped me get there.
Oh, no, yeah, definitely. I mean, I love the show. I love everything that you guys do on here, so I'm glad to help get you guys there. I know, you were kind of, the success is built off of everybody in the audience, and I have to say that you've been able to draw a pretty good audience.
They're okay. Aren't you guys? You're okay. Just let me run through a couple of announcements real quick, and then we'll get going. Tomorrow night, I'm going to do something different. Jimmy's got a little bit of a crazy schedule, so we're actually going to do Sunday Fun Day on Monday. So it'll be Monday Fun Day. And so I figured tomorrow we're going to have a little story time. I've been, as many of you know, I was in a very serious relationship for about 4 years. That ended at the beginning of this year, and I took some time off for me, and here in the past couple of months, I have been back in the dating world, and I have accumulated quite a few stories that I would like to share, because I just need to get it out. And so I figured that tomorrow I might let you guys sort of be my therapist and let me go through a couple of some of the wild adventures that I've been on these past couple of months, and we'll just have a story time. I'll open the phone lines. You can call in. We can talk and just hang out for a little bit. So it'll be you and I tomorrow. Monday, we're doing this stream on climate change. We've got somebody coming in that deals with that. We're going to talk about is it man-made and what we can do about it. Tuesday is going to be with Casey and Opinionated. We're going to be talking about abortion. That's going to be not controversial at all. Everybody will agree, and there won't be any sort of dissenting opinion. So make sure you tune in for that. Wednesday is going to be Dr. Alex Malpass and Jay Dyer. They're going to be having a debate on the tag argument. And then Thursday will be Shannon and I for another round of your calls. And then on Friday, our really good friend Adam Kokish will be back. He is making the rounds, and he's going to be stopping back in to talk about libertarianism and why it's the best way to go. Also next week, I'm thinking maybe next Saturday, we're going to do something different. I'm going to put together a Where Are They Now? Your favorite people to hate, from George Lujack to Debbie, Wotan. What are they doing now? What are they up to now? Are they doing anything? You know, we're gonna check in with them and see what they're up to. Also, in 3 weeks, it's going to be Patreon week. If you are a member of Patreon, that week you're going to get special access to pre and post shows, exclusive after shows where it'll just be made up of you guys. That week, after every show, we're going to be doing Discord conversations afterwards, and then bring some of you on the air for a couple of those shows. So it's going to be one big week all about you guys, and that's going to be coming up in 3 weeks. So, GE, do you have anything coming up? Anything you want to talk about right offhand?
I mean, I don't have anything special. I mean, next week's Sleeping Warrior Week, and Fight the Flat Earth has asked me to do a video on that. Also, I recorded some stuff for Team Skeptic, so I'm going to be on his channel next week as well. But other than that, it's just kind of normal stuff. You know me, I grind it out.
You are a grinder, I must say. You are definitely a grinder. Okay, Chris, how are you doing, sir? Welcome back.
Hey, good. Thanks for having me back. I know I was just on last weekend, so hope you're not tired of me.
Where are you? I wasn't here last weekend.
Yeah, me and Fight the Flat Earth.
Oh, okay.
You don't even know
Cool.
who's on your own show.
No, well, see, okay. Let me back up a little bit. I know that last week we were supposed to have Mock Earth and Schrodinger's cat, and something happened with that. Now, when I referred just a second ago to my horrible dates that I've been a part of, I was in the middle of that last week, and we'll talk about that tomorrow. So I wasn't abreast on the plan that went on after Mock Earth sort of happened. But nonetheless, welcome back. G, do you remember?
Yeah, I believe I do remember Chris now. Although he had a cam last time, so I guess that's why I'm not recognizing him initially. But I do remember the conversation. There was a lot of light discussed.
Cool. Did you want to go on cam this time, Chris?
Yeah, and I was on last week for Fight FTFE, so it's fine.
Yeah. Did you want to go on camera? We didn't even ask you beforehand.
Yeah, you can put me on. I've got the camera
Okay.
on.
All right, Dave. You can put him in the middle there. Okay. So, Chris, take a second and reintroduce yourself to everyone, and tell people where they can find more of you, social media stuff, all that.
Yeah, my name is Chris Berry. From Oklahoma originally. I live in Texas now, and have for like the last 12 or so years. I have a bachelor's degree. I don't have a master's degree. It's in information management systems. It's basically like an IT degree. So I'm not professing to have any special skills in mathematics or any science really at all. But I find it odd that a lot of people think flat earthers don't have any formal education whatsoever. So I do have a 4-year degree, for what that's worth to anybody out there, which again, I don't really care about that stuff, but it has come up in conversation. I've been to flat earth about 2 years. I go on Nathan Oakley show. I go on Jose J.G. Gonzalez show, and I have a lot of discussions with the people that go on both those channels. Jose has a good mix of flat earther and ball earther on there, so his has been a good show lately. I do think the earth is flat. I have a couple pet peeves as a flat earther. One is one is they think we are either dumb, unintelligent, no education, which is not true. Two, they don't believe that we actually believe the Earth is flat, which I guess I can only speak for myself. To be honest, I 100% believe the Earth is flat. And I don't know how else to explain that, or I'm not a Poe. If I ask questions, a lot of times it's it's for clarification. It's not because I'm being a Poe or what have you. So I do believe the Earth is flat, and everybody that I know that is in the flat Earth community does as well. So there you go.
Okay. Just start off preliminarily. Why did you at any time believe that the Earth was a globe?
Oh yeah, absolutely. So I'm 35, and for 33 of my 35 years on Earth, I believed the Earth was a globe. I had never looked into flat Earth. I had never, other than hearing about it and people making fun of it in passing, like, oh, what is this, flat Earth society? Or, oh, if the Earth was flat, you'd fall off the edge. Those kind of remarks. I never thought about it until, like I say, about 2 years ago. So all my education and all my learnings have been in heliocentric round Earth model and theory. So it was very hard to overcome that those teachings and the educational system to not believe in gravity, as hard as that is, to not believe the Earth is round, etc.
And so, what was it that made you switch from the globe Earth to the flat Earth model? What was it that really made you turn ship?
For me personally, it really does come down to the evidence. Just talking about seeing things too far. I mean, I talk with Globers now on almost a daily basis. And have you heard of the Rumpus?
Oh yeah.
Yeah.
Okay, so I just don't know how well known he is. So Rumpus goes on Jose's show a lot. He used to go on Nathan Oakley's show a lot, and he kind of has backed off there. But either way, he goes on Jose's, and I've talked with him, and he admits that there's objects that you can see too far based on the curve calcs, right? Curve calculators, whether it's Mick West or anybody else's. And he even admits that. But then what he does is he says, the reason you can see that object that far is because of what he calls superlooming. So what you might call standard refraction, 7.6R refraction, that Mick West sort of made famous. It takes, if you have a curve, if you have an object over the curve, it sort of lifts that object up, right? And you can then see it, and that's what they call looming. So Rumpus has what he calls super looming, which means conditions beyond standard or standard refraction. So the point is, even ballers now admit that you can see things too far. The variance in the difference is what is the cause? I believe it's because you're looking at a flat land and you're seeing too, quote unquote, too far around the ball. He's saying you're seeing too far, but it's loomed up to where you can see it.
Okay. So what is your explanation for why we can't see indefinitely across the flat Earth?
There's a couple of reasons. So this is one of my favorite arenas to sort of talk about, and by no means am I an expert in optics or visual observations by any means, but it's one of the areas of research I've done most. One of the areas I've done the most amount of research in. So the first two I can think of off the top of my head are, as things go further on a flat plane, they decrease in size due to perspective, right? So if you're 1,000 miles away from a 100-foot building, that building the angular size of that building is going to be so small you won't even be able to see it with the naked eye. Maybe with the camera, with the P.1000 optical zoom, you could, but with the naked eye you can't, and that's just due to perspective, and that's on a flat plane.
Hold on. Let me stop you right there, Chris. Let me stop you right there, okay? Because let's take things one little bit at a time. What you just said does not make sense whatsoever. Let's just get that out there right now. For one thing, we can see billions of miles when we look out into space. So the whole idea that like a zoom on a camera or a telescope or something like that would produce an image where it's too small in angular size to see doesn't really make a lot of sense when we have powerful telescopes and shit. I mean, you should be able to get a decent sized telescope on the east coast of the United States, look across the pond at and see Big Ben if, you know, it was a flat earth. So I don't know. I'm not really buying your whole, oh, the angular size would be too small to see. True, it would be too small with the naked eye, but luckily we have like, you know, lenses and shit.
Sure. So that's okay. Fair enough. So two, and probably a bigger factor, and probably a much bigger factor, is the atmosphere. And then two aspects of it. One is just refraction. The other is the density of the atmosphere that you're looking through to see an object. So you've heard of visibility, right? Like the weatherman talking about visibility, 10 miles, 12 miles, 15 miles. That means you can't see past that point purely because of the atmosphere. I don't care how big the object is, how bright it is. If it's, again, let's just use 1,000 miles for sake of argument. If there's something 1,000 miles, you're not going to see it, no matter how, you know, tall it is or how big it is, simply due to the atmosphere blocking that object.
No, see, I'm really not buying that either, because you can look with you know, different instruments in order to get past that particular hurdle, like you know, the IR cameras that they got now. I mean, you can look in different portions of the spectrum of you know, the radio. Shit, I'm blanking on what. Not just the visible light spectrum, but the other wavelengths outside of it, like IR and all that. So I mean, there are ways to get around that particular thing. Not to mention, I'm not exactly sure you're understanding like what the whole visibility issue is with the atmosphere. I mean, if you had a perfectly clear day, like for instance, there's not going to be much like air pollution in the middle of the Atlantic Ocean, you know, for you to like have to look through and all this other stuff. So I mean, you can understand why I'm not exactly buying your explanation here.
Okay, well, I mean, so I mean, for you to say you're not buying it, I mean, so let's look at some evidence. Okay, I'm not sure if I sent you a great image to use. I'm trying to see if I did, so we don't have to go to the interwebs. So pull up if you can. I sent an image. It's a 4-box quadrant of a boat. If you can pull that up.
I think it
What
was the
was
one
the
you had
previous one?
Thursday.
Right there.
Okay.
That one. So if you look at the top left, you'll see the boat is close, a couple miles, 2-3 miles out. And then if you go, let's just go right to the bottom right. That object above that black line is the boat. Now you can't see that boat for 2 reasons. Well, let me rephrase. You can't see like you can see in the top left for 2 reasons: angular size due to perspective and distance, and the atmosphere blocking and hazing it out. There's also things called diffraction limit, Rayleigh's criterion, which basically sort of combined means as things go further into the distance, the light from those objects is limited due to atmosphere, refraction, etc. And the camera, whether it's like your eye lens or even a sophisticated camera lens, can no longer see the detail of those objects, and the detail and the clarity is limited due to those principles. So that in this specific example, and we can just sort of tell, we're not even taking curvature or anything else into account. Top left to bottom right, the reason it looks like that is due to perspective and due to atmospheric blockage.
No.
Why not?
Okay. Well, yeah, I'm trust me, I'm trying to fight through the pain to explain it. So, what is your idea? Like, what does it mean for the angular like size of an object to be too small to see? Like, what does that mean to you?
Well, it means that your eye, so we know the limit of the eye is, I think it's 0.02 degrees. So
I'm
anything
not
smaller,
I'm not asking you to explain that, Chris. I'm asking you to explain what does it mean for an object to get smaller. Like that's the basic thing that I'm asking you here. Dave, if you could pull that image back up.
well, I mean, I don't know if what you're saying. If I'm not saying the object is actually literally getting smaller, right?
No. I'm not saying that the object is literally getting smaller. I was purely just asking you what it means for something to get smaller as you view it. I mean, if you just look right here, you have the very top of that boat that's still being seen at the angular resolution that it would be when it goes over the horizon. How do you explain the bottom part of it getting infinitely smaller instantaneously rather than it just going over a curve? You would have to explain why objects instantaneously get too small to see. Why does that happen?
Why are you saying instantaneously? These four images are over a period of many minutes.
Okay, so
It's not
the
an
bottom
instantaneous
right
change.
corner. So the bottom right corner there, you can see the very top of that boat. The angular size of it is the angular size roundabouts of when it went over the actual curve of the Earth, right? So
It hasn't gone
you would
over
have
any curve.
no, but it has. I'm just talking about reality here. So
Well,
the
hold on.
angular
Well, let's
size
not
is
talk. Let's
still
not even talk
hold on,
about.
hold on, hold on. Okay, regardless of a curve. Look, Chris, regardless of a curve, the angular size is big enough for it to be seen, but it instantaneously disappears. You see that, right? You see that it instantaneously disappears at that line that you have drawn. Like it does not like get smaller or anything like that past that line. It just instantaneously disappears.
Why would it instantaneously disappear?
I don't fucking know why it would, but you seem to think it does.
No, I've not once said anything about any object instantaneously disappearing. So I'm just still
No.
confused
See,
about what
I'm
you're.
explaining what your whole idea here actually entails. That's what I'm
Well,
telling
why are
you
you
right now. Is
explaining
it?
what I'm saying? Why don't you tell me
I'm
what? So
no.
let's take a step back. The question on the table is why things can disappear on a flat plane. I've told you perspective and atmospheric distortion. So if you go to the top left to the bottom right, we see both of those things. And in fact, in that same video, if you let it play, that object eventually disappears in the exact same spot you see the bottom right. It doesn't go up, it doesn't go down any further, it just disappears because you can no longer see it through the atmosphere.
Okay. Listen, if something gets too small to see, that's the reason why you're saying that it disappears, right? That it just gets too small to see.
No. I'm saying that's one reason, but I'm saying a much bigger reason, even in this example, is that, I mean, what's that boat? 6 miles, 6 miles out. Eventually, it's
I
7
had no
miles. The
clue.
boat's gone. You can't see it anymore. But it's not dropped. It's just disappeared into the haze of the atmosphere.
No, okay. So why does the haze of the atmosphere operate like a dome? Because and even then it would be like it would be an inverted
Why?
dome because things disappear from
Why are
bottom
you
to top.
talking about domes?
Well, because I'm trying to show you how the questions that come up when you say these particular things. If you look at the bottom right thing there, you can still see the boat. The boat is still at an angular size that you should be able to readily see, but for some reason, just past that black line that you have, it instantaneously disappears. It is no longer there. For whatever reason, it instantaneously disappears. So that means in order for angular size to make a difference in how much you can see of it, it would have to be instantaneously getting smaller at that exact point. And that is why it would be disappearing. I get that you're saying that atmosphere plays a role into it, but atmosphere does not play a role into what we're seeing right here. Like this right here is not atmosphere. Okay, atmosphere is causing the refraction that we're seeing, the mirage that you're seeing right there. The atmosphere is causing that. But as you can tell, up at the top left image, you can perfectly see that boat. I mean, and it's got a whole lot more atmosphere between the boat and the camera than the amount of atmosphere that's between the boat and the camera in the bottom right corner.
Why would you say that?
Why would I say that there's more atmosphere?
How is a boat that in the top left that's clearly closer to the camera have more atmosphere between a boat that's farther from the camera?
No, I'm saying like the difference, the delta. Sorry if that was a little confusing. I'm saying the difference in the amounts of atmosphere, the delta atmosphere between those two. Like you have the delta between the camera and the boat in the first picture. Like the amount there is going to be less than the amount between the boat's position in the top left corner and the boat's position in the bottom right corner.
Well, we don't know. I mean, you're making that claim. I don't even know that. I mean, this is my image.
That's how distance works.
Why can you see the top and not the bottom?
What? Say that again, Kyle.
Why can you see the top of the boat but not the bottom in that last picture?
Because of angular size, it's gotten to so small that it looks like the boat is, call it vanished, but it's just gotten smaller due to perspective.
Okay. So let's go from there. You're saying that the bottom of the boat is smaller than the top of the boat, correct?
No. The whole boat. Everything above that black line is the boat. It's the whole boat.
Right, but you can't see the bottom of it. Why?
Oh no! Wait, are you saying that the entire boat is on the is sitting right on top of that line?
Yes, in all four images. Yes, it has to be. It has to be because that black line.
That's where the disconnect
let me ask you
is.
a question. Let me ask you a question,
Hold on.
G.
I want to make sure we're on the same page here. You're saying that the boat is above the line.
Yes. For there to be an inferior mirage, the boat has to be above the line.
The very top of the boat is above the line, but the rest of the boat is below it.
No, it's the whole boat.
Chris, no.
Where's the horizon? Let me ask you guys a question. Where do you think the horizon is in these images?
Huh?
Where's the horizon in each of these four images?
Well, I mean, I think you've drawn an appropriate black line at where the mirages start. I mean, I'm not exactly sure where the the horizon is very relative to your position. So, I mean, it's not like a physical line or anything. Like the horizon appears to be much lower than that because of the water, but that's due to refraction in the atmosphere.
Right.
So I mean, I would say
it sounds like
right around. Huh?
No, go ahead.
So, I mean, I would say probably right around where you have that black line drawn at. I mean, I think that's a good general area, but I mean, I can't tell you like 100% for certain.
Right. But in general, it's where I've drawn the black line. Now, so one thing to note about that is that the line, the farther out the boat goes, rises. Okay. Why is it rising? It should be going down and dropping away. And remember, the boat's already at, so let's just say 3 miles. Okay. And it's only going further out. In the end one, who knows, it could be 5 miles out in the last picture, and it's not dropped. It's at that same horizon point in all of them, but really from 3 to 4, it's at that same black line of horizon. The water line that a lot of people would say is the horizon isn't. It's called an optical illusion due to refraction. Everything between the blue water line and the black line is water. It's just the inferior mirage has mirrored the sky onto that water, so you can no longer see the, call it the edge line of the.
Are you fucking serious right now? Because I mean, it's obvious that the person in this particular video zoomed in on those images. Like on the starting with the second one, it's zoomed in. I mean, I don't understand how you can be serious about
About
arguing
what part?
that particular thing.
Which thing? We talked about a lot of things.
Well, the thing that you just asked about, like, why does the horizon, what is it, raise up, is what you said? I mean, the camera obviously zoomed in to it so that it could continue watching it go over the horizon.
So you think by zooming in, it increases the height of the horizon line?
Well, no, I think that when you zoom in, you move the camera around, and therefore he just put the camera in a different position.
You think so? By zooming in, it actually increases the elevation of the camera by zooming in.
Okay, look at my finger right here. If I zoom in and I move it to put something else in position, like, is this physically making the horizon line move? It's moving the lens and making it centered into the picture. No.
Okay, let's pull up. No, changing the angle won't increase the height of the. Pull up the one with the jet ski. Right there. Okay, so well, that's odd. The line in the middle should be over by the jet ski. So in this image, we see what's going on. That image is all messed up.
I don't understand.
That
what
image
you're
is
asking.
literally what I was sent, so I can't help you with that.
That's okay.
Yeah.
That's odd.
Unless there's another one.
No, that's it. It's just the red lines aren't in the right place. Oddly, that's kind of that's really weird. But it's okay. Go back to it, and I'll sort of talk us through it. So those red lines. So there's the one in the kind of the middle. It's supposed to be over on the left where the jet ski is. So you can clearly see in the jet ski where
out into the ocean. Of course, that's where the mirage starts or whatnot. But I mean, that's all that situation is. I mean, you're focused in far out on the water, which is causing, or which from your perspective causes that mirage, and the jet ski over there with the pole. Those are just reflections on the actual water.
Well, right. That's what the mirage is doing. It's reflecting the image on the water. But if you go up even higher, if you look in sort of the top right, or mid top right, there's sort of three like bush-looking things, right? I don't know. I think they're part of a bridge. But if you split those three bush-looking things in half, that's another inferior mirage line. Now, the one on the farthest right, you can tell the easiest because it sort of curves up right and then back down. In the inferior mirage, right, it mirrors it, so it's not going in the opposite direction. So that one you can tell. Oh, it says the live stream's offline.
No, we're back.
Yeah, I don't know what happened, but it didn't actually die here, so
we're still on.
Okay, it's not on YouTube, but
you're talking about those
it's on YouTube for
the power
me.
pole looking things in the back.
They're next to the power poles. Those, like, I call them like bush looking things because, I mean, they're not bushes, but those call it three blobs. If you cut those three blobs in half, that's the third inferior mirage line. And again, it's rising in height because of perspective.
To me, the blobs don't look like they're symmetrical though. Look at the one on the very far right.
Yeah, I mean, honestly, I don't know what this has to do with our conversation.
Which AGE?
Well, it started out as so. Let me recap. Okay, so it started out with you asking me why things can disappear on a flat Earth, and then you turned it into things going over a curve in the boat, and I'm explaining why it's not going over a curve. When the horizon line, or the inferior mirage line, rises each step of the way, the further you go out. It shouldn't do that on a ball. It should be dropping, right? Instead, it rises because of perspective. And that plane from the bottom of the camera, bottom of the water line, and the bottom of the video to the furthest inferior mirage line, it's rising. It's going up. It's all on the same level plane. And then basically at that point, everything past that is on the same level as well.
Okay. G, did you have anything you want to say to that real quick before I ask something?
No, go ahead.
Okay, let's suppose that we just to play, just to have a little bit of fun here. Suppose GE and I grant you that you win on the photographic evidence there. It's just for sake of talking, we say that. Is that your main evidence for why the Earth is not a globe, or do you have something else that you would point to? Like, how do you explain gravity? Do you believe in gravity?
No.
Okay, what's your explanation for that?
So the best explanation that I've seen now is the relative density argument, which, I mean, I'm sure you're familiar with, but for the audience's sake, it's basically saying that the relative density of one object determines where that object fits in the relative scheme of, their environment. So if you drop a pin, the pin falls because it's heavier, it's more dense, if you will, than the air around it. Whereas if you let go of a helium balloon, the helium balloon rises because it's less dense. So it's kind of oversimplified, but that's really the gist of the concept.
Okay. Now I get that you said earlier that you're no mathematician or anything like that, but would you happen to know like how buoyancy is calculated, or the buoyant force, or anything like that?
Sure. Yes.
I'm sorry, I didn't get that.
Yes.
Oh, okay. Could you tell me what the formula for buoyancy is?
Well, I know where you're getting at, and what you're getting at is that the little g acceleration is in the formula. The problem, though, is little g, you can make things move due to buoyancy or density without changing little g, right? So you've seen the egg and the water test, where if you put an egg in normal, call it tap water, salt-free tap water, the egg will fall because it's more dense in the water. And then if you change the density of the water by adding salt and mixing it in, it increases the density, and therefore it makes the water heavier than the egg, so the egg rises. So no matter if you use the density formula or the buoyancy formula, little g isn't changing. The density and the mass of the water is changing to cause the motion.
Okay, do you know how buoyancy is actually calculated in order to know whether or not the particular object will sink or fall?
Why don't you just tell me so we're on the same page?
What?
Just tell him so that you're on the same page.
Oh, okay. Well, basically, as far as buoyancy goes, when something sinks, that means that the density displaced by that object, or not density, but the amount of water displaced by that object, I'm trying to remember when I researched this. Basically, it's a summation of the forces that are acting on the egg, right? So when the summation of the forces that are acting on that egg are in one particular direction, it will sink. And when the summation of the forces happening on the egg are in a different direction, it floats, basically. And so the forces that are acting on that's why gravity is factored into it, because gravity is pulling down on the object. And so the amount of force that is pushing up on that object, if that doesn't equal, or if it's not equal to or greater than the force of gravity acting on that object, then it will float. If the force of gravity acting on that object is greater than the force that the liquid is exerting on that particular object, it will sink. So you have to take into account some force that is causing it to go down. And can we agree to the basic laws of motion? Like, can we start off on that foot? Like, do you agree that an object that is at rest stays at rest?
And well, let me ask something here. I think this is a good question. Because since you said this a second ago, you said that the density formula gets the same results as the buoyancy formula. Can you cite the density formula?
No, I didn't say that's exactly like that. What I said was whether you use density formula or buoyancy formula when you're changing the mass, the density, which is basically changing the mass of the water in that egg example. So, for example, if you use density formula, density equals mass over volume. So to get the egg to move up, you're changing mass in that formula, if you will, in that test. So by changing mass, you're causing a movement. You're causing the motion by changing the mass. You're not changing gravity.
Well, right. You're not changing gravity. You are changing the mass of the liquid. But I mean, that's all part of the buoyant formula, and the buoyant formula requires some force pulling down on the object to give it weight.
Let's go. Let's
Well,
go
all
simple
right.
right here. Let's go simple right here. If you look up in the sky and you see things like objects like the moon and other planets, what do you think those are real?
Yes.
Okay, so if the moon is real and it's a sphere, and all the planets are real and they're spheres, why would this planet be any different?
Um, well, I mean, obviously, I can't answer that question, so I'm speculating purely based on opinion. It would have to be the uniqueness and the specialty of the Earth in terms of some type of creator. I've said this before, and I'll say it again. I don't care what side you're on. If you believe the Earth is flat, there's no way that happened by chance, right? It had to have been created by something or someone or some entity, whether that's aliens or a godlike creator.
So
So
here's my issue there though. You're willing to go out on a limb and say that even as far as aliens created a flat planet for us to inhabit. Yet when we have things like gravity, which explain that objects that have the mass that these planets do are going to pull themselves into a sphere. The mathematics are there. It can be demonstrated to be such. That explains it. Very neat, very tidy. We don't have to go into aliens maybe did the flat Earth or a God
how do
did
you
the flat Earth.
demonstrate gravity forming something into a round sphere?
You look around. Look at the moon. Look at Jupiter. Look at Mercury. All of these planets
Well, we
are
don't.
perfectly
That's
spheres.
you're putting your answer into the question. You're saying, how do we know that X is real? Well, look over there. That's X, so we know it's real, right? Or we know that that is the cause. We don't know what the cause is. It's basically it's a begging the question fallacy.
There's a formula that
You know,
that you can do
we don't
that
know. We don't know what we don't
demonstrates.
know without tests and experimentation.
There is there's a mathematical formula that demonstrates that things that they're with that sort of mass will pull themselves into a sphere. But my ultimate point, whether you want to call it a begging the question fallacy, that's fine. I'll grant you that. Why is this planet flat? And without having to move to aliens or God, why would this planet be any different? You're taking that on faith. You know that, right? I mean, it's not something that you can
No,
tangibly. Yeah, that is faith. That's absolutely faith.
that this planet is flat is faith.
Yeah, because you just said that it would have to be made by a creator. You can't demonstrate that creator, so therefore you're believing that on faith.
No, that's to the question of why would this place be flat and everything else be round? Which, by the way, that's an assumption in and of itself. We don't know that they're round. Spherical. They're round, but a plate's round and it's flat.
So these could be just angled at such that we're seeing it flat when we look at it.
Yes. Or it could be I don't know what you call it, a sphere cut in half. A sphere cut in half. I mean, who knows? Like, we don't know for sure what the actual shape of those objects are, other than this circular, basically what your logo is, a circular disc.
Okay, so if that were the case, why is it that we can see different texture on those particular objects? Like, as well, as you know, in reality they rotate on their axis. How, I mean, how do you explain that? Like, you might be able to get away with this whole plate theory with the moon because it's tidally locked with the Earth, but I mean, other planets rotate. Like Mars, it rotates, and you can actually get telescopes here, powerful enough, just like any regular consumer can go and get a powerful telescope and see Mars. And I mean, you can see it, and you can take pictures of it, or even video of it, and you can see it rotating. How do you explain that?
See the topography of it.
What?
I mean, honestly, I don't even want to go there. I just don't have the knowledge about the stars and planets. I honestly haven't done a lot of research into that, because I like to keep my focus onto the Earth and the ground and the sea, the water.
Okay.
It just
Well,
looks
okay, but,
at the
I mean,
sky.
it's a bit of a hypocritical stance to take, don't you think? Because you know enough to know that they're not spheres, or at least know enough to doubt whether or not they are spheres, but you don't know enough to offer an explanation for that.
Yeah, if let's move to planetary bodies that affect this Earth, then, that I think you should know of, because they affect our everyday life. The sun and the moon. What's your view on them?
That Well, it's a general broad question, but basically, I believe that what you might call the generic flat Earth model is that something like that is happening, where the sun and moon are smaller and closer than we've been led to believe, and that they rotate around the, call it, flat plane of Earth.
So, okay, so in Dubai, there's the Burj Khalifa, tallest building in the world. You're able to watch the sunset on the bottom floor, and then take an elevator up and watch the sunset again on the top floor. How does that work on a flat Earth?
Well, I mean, there's a couple ways. By raising altitude on a flat Earth, you're changing the angle at which you're looking at something. And that angle change can allow you to see more further on. It's the same reason when in all these videos that you see of like planes and high altitude balloons, that as those balloons or planes rise, that the horizon rises with those, with the object, the plane or whatever that's going up in the sky.
No, but it doesn't. It doesn't,
Yeah,
though. Like, there are multiple videos out there of drones going up, straight up into the air, showing that it does not rise, or whatever the fuck. Like, it just simply doesn't do that. Also, I would love to know how your explanation
I've
for
seen videos that show it rise, so.
Huh?
And I've seen videos that do show it rise, so.
Okay, well, I'm gonna have to call bullshit on whatever videos you found on YouTube, because that's not actually how it works. Second thing is with the Burj thing. I want to know how that differs from a globe Earth. Like, do you think that on a globe Earth, like, you don't change your perspective when you go up higher? Like, you don't change the perspective from which you view something at? Like, you don't see farther on a globe Earth?
I guess you could, but then in my opinion, that's a wash for both. It would work on both models.
Here's why it's not a wash.
Okay.
If you're looking at it from the top of that building on a flat Earth, you should be able to see that sun for a lot longer. It shouldn't set at the same pace that it would when you're down on the ground, but you're still seeing it dip over somewhere. If you're up to the tallest point that you can be on a building on a flat Earth, you should be able to see that sun continuously, because you're up there higher with it. It's not dipping down anywhere. Your sun,
You
according to
will
you,
see it again.
rotates this way. But if you're looking at it
Yeah, but
from a globe, it's dipping down over the horizon. Why is that?
well, I mean, if you think about in terms of the differential change in altitude for something that's that far and that high, anyways, let's just say 1,000-foot building, right? That's pretty darn tall. 1,000 feet in altitude raise versus the sun, that's how many thousand miles away and how many, say, 1,000 miles up. That's nothing. That's, what is that? A 1% change in altitude, or probably less. I don't know, just off the top of my head. So I don't think that raising, if your question is why would you see it for a lot longer, well, you would see it a little bit longer on a flat Earth too as you go up, but then eventually it will, quote unquote, go over the horizon or drop out of view on a flat Earth too.
Not at the same rate, though. That's the thing. And while on your model, the sun would have to change size, and on the globe Earth it doesn't. It stays the same. You can put a solar filter on the camera and watch the sun never change its size as it tracks across the sky. On your model, it should shrink as it gets further away from you.
It depends. I think there needs to be more research done in that area, because I've seen people do videos where they show the difference in perspective of an object on the floor, and just by raising the camera, they can change the size of multiple objects in the field of view of the camera, just by raising the altitude to look like 5-6 feet. So the point is something that far away, something that high and that size, the change in angular size could be minuscule. So I don't know that that's true statement, and I don't know that again that's an assumption that the flat Earth model says that this angular size of the sun has to change.
No, it would
So
have to.
at 1,000,
Have to. Sorry, G, but it would have to. If it was moving away from you, it would have to change size. It couldn't stay the same size as it tracked across the sky. That wouldn't make sense. On your model, it would have to get smaller as it moved away from you, but it doesn't. It stays the same.
Well, let's not say words like it has to, because we don't know. None of us know for sure if it would or wouldn't. We're going based on our experience with perspective on the ground, with atmospheric refraction going on, etc.
No, it would absolutely have to. If in order for it to work, in order for it to get dark, it would have to get smaller as it moved away from you, because it's not setting over anything. It's just moving away. It's going away from you.
Well, yeah, and it's not just a little bit smaller. We're talking drastically smaller. So, I mean, do you think that the sun like dips below?
Well, what's your evidence for that claim? What's your evidence for that claim?
That it would be drastically smaller?
Yeah.
I'll show you.
Because that's how perspective works.
That's how
like
perspective.
that's how, like when you say angular size. Hold on. When you say that the angular size gets too small for that boat to be seen, then you have to understand that that's what it means for the sun when it's going away from you. It's getting smaller, and then you can't see it anymore.
In that example, at that altitude, in those conditions, with that small boat, that 10-foot boat, that's what happens. I'm saying I don't know for sure if that's what should happen with an object like the sun that's so far away, so high in the sky, and so big.
How far?
Here's the Earth right here, and here's the sun on the globe Earth, right? Just imagine that all of these are the same size, right? As it tracks across, and let's say you're here, as it tracks across the Earth, it rises up over this peak when it comes up, and it sets down over here, right? These don't change. The size doesn't change because it's moving across. It's not getting away further away from this. Yeah.
Uh-huh. So the way you drew it is the way that you would see it on a flat Earth, because at the point where it's coming over the horizon.
Yeah.
Right. Let me say something real quick before you change that. Keep that up. So at the point where the sun is coming up over the horizon is the same point that you have drawn there. So from this angle of the sun to 12 o'clock, so let's say it's 6 a.m., 12 noon, to 9 to 12 p.m. or whatever, that works. The vantage point of the viewer where they are, it's the same thing as what you've drawn. Horizon to horizon.
Okay. Let me show you why it would work on flat Earth.
Why do we see it go below the horizon? Like, I get it, like, are you saying that it goes below the horizon because of angular size?
No. It's
Okay.
my understanding. The research I've seen, it's due to refraction.
Oh, so
Okay.
so you're the whole personal dome theory kind of guy.
Right here. Here's the sun.
Well, again, I
Here's
don't
the flat
really
Earth.
know what that means.
Here's the sun. Here's the flat Earth. Here's it. This is the path that it takes, right? If you're here, this is where the sun spins across the flat Earth, right? If you're standing right here, as the sun moves and arches back here, it's going to get smaller as it gets away from you. That's how it has to get dark. Otherwise, how do you explain where it gets dark from?
We'll see in
With
that
the
the way
globe,
you've drawn it.
it's on the other side.
That's a really good drawing, by the way. The way that you've drawn it, I mean, obviously it's not to scale, it's not to perspective. If you're at a point on that map that you've drawn, you're going to look at the same horizon to horizon line as you would on a round Earth. The point of that the sun goes down and crosses the horizon is the same point on a flat or round Earth. There's really no difference. It's pulling it down due to refraction.
On a globe Earth, it's going to go curve like back from us and set from us like this, right? On a flat Earth, it's moving like this on top of us. It's not coming across. It's moving on top and pulling away like this. It's getting closer
Yeah, but
to
by
us.
the time, right? But by the time it goes, quote unquote, over the horizon,
There
it's the
would
same
actually
point as it
be.
would be on a flat Earth. I mean, a round Earth.
This is the producer.
No.
I've
What we're asking is, why is it going below the horizon in the
Right.
first place on a flat Earth?
And why isn't it some
Well, no, that's
giant
the second question.
angular change in size? There would be a 400% angular difference in size between noon
Where do you
and
get that
sunrise
number?
and sunset, because that's
Where do you get
math
that number?
goes.
Basic geometry.
Basic
Where's
geometry
the
of
math?
the
Let me see the math.
$3,000. Well, I don't have it to send to you.
I mean, you
Then
were
why are you
just
claiming
arguing
that?
for angular size earlier, and now you're trying to say,
Right.
prove to me shit gets smaller as it gets farther away.
Thing is, like, if it stayed the
Well,
same,
in your model,
sun
hold on. In your model, it's getting farther away.
stayed the
No,
same
it's
size
not.
as it moved across a flat Earth, how would that work? How would it stay the same size when it's up over my head and it moves to Australia? How would it stay the same size? It would have
Because
to
by
get
the time-
smaller.
No, by the time it's gone, it hasn't traveled far enough to make any difference. It's like on a round Earth. Why would the change in distance why would it be the same on all points?
Because it's going around a curve. It's going around
Well,
a curve. And
So as it's going away from you around, is it not further from you than what it is?
hold on, Chris, hold on.
No.
So the explanation for that is that the sun is 93 million miles away, and it's really freaking big. So the change in angular size is not really all that detectable from here on Earth. Now, as we rotate away from the sun, do we get farther away? Sure. I guess technically we do, but it's not enough for us to detect like a change in angular size from our place here on Earth.
Right, and that's
So
my
now
answer on
I've
flat
been able to explain that to you. Explain to me why the sun does not change in angular size and it appears to go below the horizon without using Jeranism's dome theory that you seem to claim to not really know about.
Dave, will you pull up Red's video on the with the solar filters? We can look at that too.
Let me find out real quick.
Go ahead, Chris.
What? Sorry, re-ask the question on.
How does he was asking?
Well, we need to know why it doesn't change in angular size, the sun, and then also why does it appear to go below the horizon? Refraction does not actually account for this.
It doesn't change the angular size because the change in distance from your point to the point where the sun meets the horizon, not where it's at when it's in Australia, but when it meets your horizon, your eye line to the point where the sky and the ground meet and converge, right? At that point, the sun hasn't gone far enough away to change in angular size.
Okay, so you're saying that the sun just hasn't moved enough in order to change an angular size, but if it's close to the Earth, we should see drastic changes in size. This is just basic math.
Again, it's relative. I don't know the exact distance, size, or height of the sun, so
That's what we have math for.
maybe there's a slight change. I have seen videos with solar filters that do show a slight change. It's very, very small. It's like
No.
couple of pixels.
Well, no. What you're seeing is a changing glare, and that's easily
No,
solved with a
these
solar
are solar
filter.
filters. These are solar filters.
Okay. Well. Then you're just forcing it to change when it actually hasn't changed. Then, or there's some other thing that's causing it to change because there's literally no change in angular size of the sun when you appropriately use like a solar filter or something.
We're going to show you
So-
here in just a second. Whenever Dave.
Well, and again,
I mean-
it's fine. I mean, you can show me a video and that's fine. But again, what are the conditions of the climate that person was in to take that video? Was it a wet climate over water? Or was it a dry climate in the desert somewhere?
The climate's like the sun size stayed the same. None of those factors would come into play with the size of the sun. It stays the same as it tracks across the sky. Here you go. You'll see. This is with a solar filter. Go ahead, Dave.
So Sean Hufford's actually
Pretty cool. You can
messaging
see a
me.
sunspot.
Yeah. So
What are what's the official explanation of a sunspot? Do you know?
Go on, mass ejection.
I mean, I haven't looked at the science behind sunspots, but I know I can figure it out.
Like a storm on the sun, I think.
Okay.
so this
And I've seen those before. I just think it's interesting how they stay there and they don't really go away for a while. I mean, it's not like a flare.
A lot of fusion happening there.
So, I mean, look, did Red do an analysis where he took the first image and the last and compared them or something? Or is it just the video of this big?
He's done it several times, even live on this very channel.
yes.
Yeah, he tracks it
They
in
do not change in angular size.
not once.
Okay, well, look, I mean, you're showing me a video of something that I admitted that is still possible on a flat Earth because, again, at the point where it crosses the horizon line, it's possible that it's just not far enough to change.
No. You're wrong because that's not how it would happen on a flat Earth. If angular size is the reason
How do you
why,
know how it would
then
happen
you
on a
need
flat
to come
Earth?
up with a better reason.
How do you know how it would happen on a flat Earth?
Because we
Because
watch things.
I've heard your model for how it's supposed to go. And if it's that's why I said
all I
if
have
it's
to do is
angular.
the Earth is
Hold on.
flat and the sun's
If it's
doing that.
angular size, then you need a better explanation because it's not changing in angular size or anything like that. It also
don't know
doesn't
that.
tell us why it appears to go below the horizon.
Well, that's a different answer, and I gave you that answer. It's refraction.
No, diffraction does not explain this.
Refraction.
Refraction doesn't explain this.
Well, I've seen. So I don't know if you've seen Rob Skiba's test, where he used like a Fresnel lens to represent the atmosphere, and as he pulled his sun away on a flat plane, the refraction of the lens, which is what it's doing, it's refracting the light, pulled the sun down exactly like you would see a sunset.
Okay.
And then I've also seen a
so
3D computer model do the same thing.
all right. So now, does the atmosphere have the refractive index of glass?
maybe 2,000 miles of atmosphere might. I'm not sure.
Well, no. Okay. So the answer to the question of is the atmosphere glass is no. The atmosphere is not glass.
That's not the question you asked.
I asked if it had the same
Does the
exact
atmosphere
refractive
have
index.
Right, and a half-inch piece of glass versus 1,000 miles of atmosphere might have the same refractive index.
No, it's not. That's not how that works.
Why not?
The atmosphere is not
It's
like
a
glass.
gradient. I didn't say it was. You said the refractive
That's what
index.
that particular model implies, is that the atmosphere operates like glass, and the atmosphere does not operate like glass.
No, it operates as a density gradient.
Which glass would not be a density gradient.
Well, it's a change in the density for the light. That's why it's refracting in both. So refraction in both models is the same. It's light bending due to a medium, whether it's a Fresnel lens or the atmosphere. The light is bending. So you're just using the Fresnel lens on a small scale as something to represent or recreate refraction.
No, that is not how anything works.
Okay, I don't think we're going to agree here either. Let's try something else then. What about the constellations? How do you explain those?
The constellations. It's a
How you can
it's, well, it's,
see a group of constellations from one point that you can't on another, whether a different point on the planet. That would be explained by being on a sphere, because you're on this point of the sphere. You're not going to be able to see the same constellations that you can on this point of the sphere. If it was flat and everybody was on the same plane, all of them you should be able to see them at the same place from any point on a flat Earth.
right. So a similar answer to the sun. It's the angle change due to perspective as you move away from something. The angle, let me see on the camera. The angle, if this is the star and you're moving away from it, as you move away, that star is going to pull closer to the ground, just like the top of a building would. If this is a 100-story building and you're standing next to it and you walk away from the building, the top of the building, well, it doesn't really drop, but it's going to appear to drop due to perspective. The star is doing the same thing as you go away. It's going to drop and hit the horizon.
Okay, so let me
No.
let me ask you this: are the stars as close as 100-story buildings?
Probably not.
Okay, how far away do you think the stars are?
I don't know.
You don't know.
No.
How if you don't know, then how can you say that they operate like that? Because that's not actually what we see in actual observation.
Well, why not? What do you mean it's
Like
not what we see?
Okay, let me see if I can put it a different way. When you actually do that in reality, that is not what you actually see. Like as you go down, like if you start at one end of the road looking at a star and then you go to another end of the road and you look at the star, it does not actually change position in the sky. It doesn't get closer to the horizon. It doesn't do any of that.
Well, you're talking on the other side of the planet, they're seeing a completely different sky than we are. How do you explain that?
Look, again, my specialty and knowledge is not with the sky, so I don't know this fascination with globe Earth
sure.
to go
And
to
that's
the
fair.
sky
That's fair.
of the Earth.
That's fair. But what I'm saying is the ultimate point here is that all of these factors play into the shape of the Earth. It's not just one of these branches, like water and refraction, or the constellations, or the shape of the other planets, or the sun and the moon. But when you take the totality of all of these points up, the flat Earth model just falls to pieces. That's why I said earlier, let's say that we grant you that you take the refraction point. Let's say that G and I say that you win, that. You can take those points. Everything else that has been lined out here tonight destroys that model. So are you going to hang your hat on the fact that there's mirages over water compared to everything else, compared to the totality of everything else? I mean, how can you do that?
So the way would answer that is, if you can prove the Earth is flat or the water is flat from the surface, then everything else has an explanation to it. Just because we don't have explanations today or tomorrow doesn't mean there aren't alternative explanations.
We do have explanations, though. We have very
No, in the
flat
Earth model, call it.
Yeah, but that's the thing. You're saying that you don't have them yet, but this side does have the explanations, and it does line up with what we see in reality. So why do you feel the need to hold out on the slim chance that somebody's going to disprove the things that we already know on these aspects, even if we give you the refraction thing with the pictures? I mean, that is not that's when you do the totality. Like, I just believe in. I had a conspiracy that I held dear to my heart. I thought that the Sphinx was older than mainstream archaeology told us that it was. It was something that I firmly believed, and I fought tooth and nail on this show for about 6 different episodes against Egyptologists, archaeologists. They would come and tell me otherwise. And then one show, Dr. Bob Sneaker came in and explained every question that I had. It made sense. It fit. There was nothing that I could push back on, because my pushback would have been way more outside the realm of reality when his fit perfectly. And I had to admit, okay, the totality of the thing, it seems like it is what they're telling us that it is, and that killed me. I hated it, admitting that was the case. But I also believe in going after truth and looking at evidence for what it is. And when the evidence is staring at you right in the face, even though you might not like it, and there may be some you may still have some questions on some things, the totality of everything points very clearly to one side. And you're telling us all of these reasons why it couldn't be this, or I don't know this, or we're still waiting on this. Why fight back that hard on something just because you don't want to admit that, yes, it may actually be true that the Earth is a globe?
I don't think I'm fighting so hard. I mean, honestly, I'm open to the evidence. And again, for me, the evidence is on the flat side. Now, again, I don't like going to this. I don't know why people go to the sky to prove the shape of the Earth. I think that's a little bit weird. I think that you would want to go to the ground and the land and waters to prove flatness. And I think there's ways that we could do that, right? I mean, there's plenty of laser tests have been done. They have what are now they're calling these mirror reflection tests, where they'll take a 4-foot mirror on one side, and then you'll see the reflection of sunlight 18 miles away on the other shore, with about
Okay.
5 feet of average height on both sides.
He and I had a guy on here about a month ago that he deals with measuring, like when you have a tsunami come in. His job and what his company does is they develop technology that is so sensitive that they put it in the ocean, and it's able to measure the actual curvature of the ocean for the purposes of these tsunamis and the ready responses. He came on and he did an entire presentation on how these things work, showed the data, showed that you can track a measurable curve. I mean, these things are like super sensitive, and I'll see if I can find the links and link them in the description of this video too. But you're able to go in there and see the actual ocean's curving.
I've not seen that, so I can't really comment. But I would like to watch it. If you can link it, I'll watch it.
Well, and what the ultimate point there is that these countries rely on this data for the prevention, and emergency preparedness. That's what they do. It's a predictable model that they rely on, and it works. You can see it. Quedgy.
Well, I was just going to explain the reason why the sky is important as far as, knowing whether or not the Earth is a globe. The importance of the sky is that the sky would look very different on a flat Earth, so that's why we look to the sky. We also look to the sky to know a lot of other things in like astronomy and physics and stuff. So, I mean, that's why the sky is important. The fact that you can't see the Southern Cross from North Alabama is a very big problem for the flat Earth. The fact that you can't see Polaris from the underside of the Earth is a really big problem for the flat Earth. You can't just get out of it with perspective and all that other kind of shit. That makes literally no sense with how we know reality to operate.
Yeah, you can't see those systems.
Well, look, I mean,
honestly,
I'm
I'm questioning whether or not you know like what it means for things to get smaller at this point. Like I know that you say you're not a Poe, but I really cannot understand why you don't understand the concept of shit getting smaller.
Yeah, that's what all this boils
how
down
would I
to.
not understand that?
Well, with the sun,
What is the
with
With
stars.
sun? We don't have experience with the sun and where it is and all that. We have
Oh, we do.
experience across the land.
It always rises
No,
to the
not
east
with
and sets in the
perspective. Not with perspective, we don't. We don't know what's going on up there that might change the way that perspective is working in terms of the size and the distance. Again, I've seen a video that had a ball, that two balls, and the ball in front was bigger than the ball in the back. And the guy raised the camera up 6 feet, and then both balls were now the same size. And all he did was raise the camera. That's it. He didn't change the zoom or anything.
Yeah, what does that mean?
It means that you can change the size. It means that you can change the size of the objects based on your altitude.
Yeah, that's compared to another object. You had a big ball and a small ball. There's only one sun.
Yeah. Can I ask something? Was the other ball 93 million miles away from the one ball?
But there's only one sun up in the sky. Like what is that? Yes, I'm sure you can get a specific angle to get two objects equaling the same size, but there's only one object in the sky. There's only one sun. What would raising or lowering a camera angle do to that one sun? There's nothing else to compare it to. There's only one sun in the sky.
Also, it doesn't explain why when you're just on the face of the Earth, the sun should be getting smaller on a flat Earth, like drastically smaller on a flat Earth. Like you don't change altitude there. So I don't understand what this has to do with that particular thing.
Well, it's just sort of showing that if something's high enough, or as you elevate, you can manipulate the call it size, the angular size of the object.
Where's Shannon at? Is Shannon watching?
Yeah, I saw. I don't know if she's still watching, but I saw her in there just.
So as a flat earther, one thing we have to be careful of is saying your model says this wouldn't work on your model. That's not how things work, right? Because again, we don't know how things would work on a flat Earth model necessarily without doing proper tests and experimentation. Looking at something in the sky and saying that you live on a round Earth because of that, that's not evidence.
No. See, I purely disagree with you on that point. Like, we know how light operates. We know the fact that like light has a certain speed in a vacuum. We know these things for certain. So, like you explaining that that we can only see so far out into the distance just doesn't make sense, because we should be able to see Big Ben from the east coast of the United States because of how light operates.
Just explain why you wouldn't be able to see it.
Here's the thing though. Like let's take that argument, right? Let's take a basketball, okay? Let's say we know how things work with a basketball. We know how things bounce and you're able to roll it, that sort of thing. We can still tell you what it would be like if that basketball was a flat disc, and what would happen if we tried to bounce it, or if we dropped it, or if we rolled it. Just because something it is like you can't prove something is doesn't mean you can't demonstrate what would happen if that were the case. If you were to have a sun that was local and spinning away from you, you could absolutely run models and tests and show exactly what how that would work if that was reality.
So let me read a definition, because I mean, after this we've been almost an hour and a half, and Godless engineer still thinks you can see something 1,000 miles away. So if you look up what visibility, it says in meteorology, visibility is the measure of the distance at which an object or light can be clearly discerned. So again, literally you can't see things 10 miles away because of visibility. Like, it doesn't matter how big they are, or whatever. It's the visibility factor of the atmosphere. Fog,
What do you
mist,
think the
haze, and
atmosphere is
freezing.
made of?
It's made of gases and, well, water vapor is a gas, but it's made of water vapor and many, many gases, and
Okay,
smog and
okay.
that.
Right, but I mean, shooting, looking across the ocean. I mean, do you think that there's like fog banks and shit, like just out in the middle of the ocean? So anyways, do you know what radar horizon is?
No.
Um, Okay, so radar horizon is basically when you have a radar system that's used for detecting, aircraft, basically. And when you beam these out, right, you're looking across the spherical Earth, and at a certain point you can't see any farther down. But if the airplane or whatnot rises to a certain elevation at its local spot, the radar will be able to see it again. How, like, without it actually changing the distance, like, between the two objects, why is it that when it gets higher in the air, it can see it again? Like, I don't know. I don't have like a drawing or anything that I can show you or whatnot.
Well, I mean, can we get an agreement that due to visibility you wouldn't be able to see Big Ben from East Coast?
No, on a flat Earth
So
you would be able to see big.
you're denying visibility. You're denying the visibility factor of the atmosphere.
There's so many
No, I'm
factors
not
that you have
denying. I'm
to.
not
I mean,
denying the visibility factor. I'm just denying the fact that you think that we wouldn't be able to see Big Ben on a flat Earth.
Why would you think you'd be able to see Big Ben from the East Coast on a flat Earth with visibility factor?
big.
Okay, listen. I know that you don't think that the moon is 240,000 miles away, but it is. Okay, if we
What
can
does the moon
see the
have to do with the
moon,
visibility factor on the Earth?
if you can just let me finish my sentence right here, you might understand. The moon is 240,000 miles away from the Earth. Okay, if we can look at the moon rise or set at the horizon and it's 240,000 miles away, then with a big enough telescope, we can definitely see Big Ben from the East Coast.
Yeah, and
We're
like
looking through the exact, huh?
I don't think I don't think in this. In I'll tell you what. In this final like couple minutes, I have I want to go a different route. Just to ask you, just because I'm curious, because you alluded to it earlier when you said that there had to be a creator involved. What's your like religious leaning? When you say creator, like, do you have a personal view on who you think shaped the planet?
No, I don't. And that was one of the really hard things about the flat Earth, was I was also an atheist my whole life as well. I never really ever once believed in God, except when you're like a kid and you're sort of indoctrinated with religion or whatever. But I mean, at least by the time I was 10, I never believed in God from that point on. So that was sort of a hard one for me to swallow. But no, to answer your question specifically, I don't this. I don't lean to a specific religion necessarily. I don't have a thought on what the creator is. Again, if it was some sort of alien or if it was like a god type entity. But I will go out on the limb, as you said earlier, and say that if it was flat, it was created.
So then there's where I find what I find interesting. Why pick up the okay? Let's say again, I'm going to grant you the flat Earth belief, and that you hold dear to that, and you believe it 100%. Why pick up the God factor, or that there was something else if you don't have to? Like if there's nothing that kind of screams out at you that there's a reason for you to believe in one. Why pick up that extra belief?
I don't think it would even be a belief. I think it would be an evidence-based claim. You can't have a flat Earth where everything revolves around it if it wasn't created. That cannot happen by chance.
But you don't even know if for certain that the Earth is flat. I mean, you freely admitted that. So
yeah, no, it's an assumption. It's an assumption that if the Earth is flat, it had to have been created.
Right. So you see what I'm saying? You're picking up all of these extra things that almost like baggage. All of these extra things that you have questions about, you can't really prove, but you're taking them on anyway. And I'm just curious as to why do that.
I believe it. I believe you can prove it. I think that when I look at a piece of evidence and you or Godless Engineer looks at the same piece, I see evidence for flat Earth. You see evidence to the contrary.
Yeah.
Why
Yes,
is that? I don't know.
I feel you on that. But see, you're looking at that evidence, and that evidence is causing you to say, because of what I see, it's either a God did it, or even like you're even willing to put out that aliens could have done that. And I'm fascinated at the motivation behind that. Like, because you're not willing to give a little bit that NASA could be right, and that this could be just something that the people have genuine questions about, that they're more than able to question. But you're dead set on them being liars and this big massive cover up. But you're also at the same time willing to say, but aliens created this planet that we're on. And then that opens up so many more questions. Where did the aliens go? Where did they come from? Why did they just create this this planet and leave? Like, you see what I'm saying?
Right. Well, yeah. Well, did he have an infinite regression fallacy or issue, right? Where then who created the aliens? Right. But that. I mean, I don't see that as sort of the point. I mean, if it was, I'm saying it's an assumption. If the Earth is flat, it had to have been created by what or whom, I don't know. I believe that. I don't know.
That's a good answer. Yeah, that's a good thing too. I mean, just to me, we're reading super chats now, but Chris, like I would just not pick up. I mean, the alien, you're having to explain away things more by picking up these other, assumptions. And
so,
because
can I ask you,
for whatever reason, people are so, yeah, please.
If you thought have you ever entertained the idea that if the Earth is flat, what that means?
I do every Saturday.
So what do you think then? Do you not agree that do you think it could have happened by chance?
That's a good question. I wouldn't know, like, if I genuinely felt that the Earth. I mean, that's really difficult for me to answer. But if I genuinely felt that the Earth was flat, I probably would have to think that there are so many things that would be unexplainable, like why we are the center of the universe, why the sun revolves around us, why this happens, and it doesn't really have an explanation based in any sort of reality. These things would just be happening. It would have to be like somebody set them in motion, because they go against what we know to be true based on physics and mathematics and that sort of thing. So I would have to think that there would be somebody going against all of this stuff. But my question to you is your grudge against a government or an agency that absolutely has lied in the past, absolutely covers up things, absolutely tells lies straight to our face. Is it worth having to break down all of these questions that you're picking up when that side has answers that fit perfectly and explain everything, or if not everything, most everything?
No, it doesn't have to do with the grudge against the government, who has lied in the past, as you said yourself. But for me, speaking for myself and not overgeneralizing all flat earthers, it has to do with the research that I've seen and done myself, by the way, and the evidence that I've seen others do, and points to the conclusion that the Earth is flat and state. We never get into the stationary part or the movement, then that's fine. But that is flat and stationary, and that everything revolves around us, which either means that we're special or it means we're in a prison and we can't do anything about it. So
I have so many more questions, but unfortunately, I have to leave it there. Let's see. RJ, I don't know how else to make a one-time donation. Thank you, RJ. You did it. Trevon Hudson left a super chat with no.
What the hell just happened?
Oh, I don't know.
Like, seriously. All of a sudden,
It seemed to have died.
VMix just was not running it. I'll start the stream again. If it'll start. Is it going?
I think so.
Are you back yet?
Chris,
I think so.
I'm here.
Okay,
Sadly.
I think we're back.
Back.
Well, I thought we had fixed the problem, folks. Apparently, we have not.
I don't know why that happened. All of a sudden, VMix just wasn't running anymore.
Yeah.
Okay, well, we'll do something. We'll fix it. Everybody. Chris, what is diffraction?
I don't know if Chris is here.
Okay. The Athens 619. You need a model that accurately depicts reality. Flat Earth does not have a model and can't agree on one. The Flat Earther tried to make one and was ostracized because he couldn't, since what math describes is reality. Jade Dragon Melee, holy shit. Tommy Granvold says, what do I need to do to get in there? I've got enough on reservations to show this guy's wrong. Sent mail 2 weeks ago. I have not gotten anything from you, Tommy. You could maybe resend it, and that's live at nonsexshow.com. Aphotic New NZ says, Chris, don't you find it weird that you're fumbling for explanations for everything? Or flat earthers have become extremely boring. All they do is repeat the same old prats on and on again. None of them ever bring anything new. Or God forbid, should they ever bring any positive evidence for their model? Aphotic NZ says, yes, it's all explained perfectly by curvature and gravity. Funny that you have to make up the truth. Solomon 109, thank you, Kyle, for having a decent flat earther on. Space, comma. Magic is not an explanation. Concord 327, this poet died in front of a church in Baltimore. Shannon Q, I had some drinks, so I decided to try and watch one of these. I've made an error in judgment. Corrupt syntax, I give my money today, not for losing your chat today. Thank you, Dave, for what you do. Night Demon, I use a telescope with a equatorial mount. You have to adjust constantly for rotation. Please explain, Mr. Poe. Thomas Braun, without Sigma Octantis and the Southern Stars, the Athens 619, alpha equals 2 times arctan G divided by 2R is the law of perspective, and it said it would grow and shrink. Curtis Vanguard says the flat earther's horizon would be the edge, as standard refraction would bend the surface towards what appears as concave or bowl-like shape. Humboldt Hipneck says he has the intellectual honesty of a car salesman. Space comma comma. This is not how it works. The most said phrase in this stream. Oxtal left a super chat with no message. Gravity acts, no evidence, no understanding, no clue. Callie Ann Holland says, I want to have a dumpster fire scene from Jupiter. Are in Rob versus Russian vids. Subject is evolution true, and are we monkeys sticking to a spinning globe? I'm actually trying to get Aaron Ron and Jesse Lee Peterson. That's what I'm working on now. So
That would definitely be worth a watch.
corrupt syntax. Frank me, that's it. I'm driving this semi into the nearest car of flat earthers. Just kidding. Not really. And then translator Cranium says a creator wouldn't necessarily follow from flat earth. To claim otherwise would just be another theological argument with all the same flaws. Let me refresh and make sure that I'm not forgetting anyone. Space comma comma. The government does not exist. And Artisan Tony, again, with congrats on 30,000 subs. Love you, mean it. I read yours earlier, Tony, but as always, fuck you. Thank you, though. But yeah, all Autistic Shield says, what do first say about mountains? Not today, Satan. Yeah, but okay. So I think the takeaway here for tonight is that if you have a point that you are convinced of, that you are absolutely convinced of, and that no one can explain away or give you a satisfactory explanation for, with that, when you're talking about something as important and as complex as the shape of the planet that you're on, that is not the only factor going into it. You can apply this with many other things, but we're going to take the shape of the planet here. You may have one or two things where no one can refute you on, and you are convinced this is the way that it is. However, if you take the totality of the evidence in every aspect, from what we talked about tonight, being the water, the skies, the other planets, gravity, the sun and the moon, when you look at the totality of the situation, you have got to be able to be intellectually honest enough, even when you're wrong, to see how when you have checked all the boxes in this column and you've only checked a couple in this column, that it's more than likely the case that this column is the truth. This column explains exactly what reality is, and you just have to get over the fact that you still have questions that you don't think anyone can answer. Because it is absolutely dishonest to have all of these check boxes, not have an explanation for them, only have a couple over here, and then say, fuck all of that. I'm pushing it out the side to hold on to these these one or two things over here, just so I can keep my my viewpoint, so that I don't have to admit that I might be wrong, so I don't have to admit that maybe there might be something to these NASA people after all. It's aggravating to see that. And Chris seems like a nice guy. I hate the fact that he was once an atheist and is now, because of this, having to pick up that cross of religion again, or that there's something else out there, and just tack on more and more and more things that he has to explain that he can't. G.
Well, yeah, I mean, I had a fun time in this discussion tonight, and I appreciate Chris coming on, even though I kind of started off in an asshole-ish kind of manner. I'm sorry about that, but I really appreciated the conversation. I do know that Team Skeptic was wondering if you wanted to be on a after show kind of hangout. So I don't know if you'd be up for that, Chris, or not, but I can give you his email if you want to be on that.
Yeah, you can give it to me.
Chris, I didn't know you're still here.
Yeah, I'm still here. I joined back.
Here I was talking to you like you weren't here. I'm sorry about that. I didn't even. I've got my super
That's
chat
all right.
page pulled up.
Hey,
but yeah,
can you blue wrench me? It's hard to respond to people with the limit.
yeah. If you
I don't know if you wrench flat earthers or not.
No,
Fight
yeah,
the
where
flat
you at
earth
in the
does it.
chat?
Here, I'll post. I just posted. Fight the flat earth says he doesn't
Okay.
wrench flat earthers, so I was like, okay. I didn't know if you did or not.
Yeah, I trust you. Yeah. So
Thanks.
sorry, Chris. I didn't mean to talk to you like you weren't here. I would have said the same thing.
Oh,
Like,
yeah.
I feel bad that you're having to pick up these extra things that you can't explain, and I just wish you'd look at the totality of everything and not hang on to a couple points because you think that people can't refute those. Now you can respond,
Sure, and
then
I just
we'll
want to
close
be
out.
clear. Yeah, I just want to be clear. A lot of times people say, "Oh, you're religious, therefore you believe in flat Earth," and maybe that's true sometimes. For my case, I want to be clear. I was an atheist, globe Earth believer, came across flat Earth, and now I'm starting to believe or do believe in some type of creation or creator. So I just want to sort of set that straight. Sometimes people flip those around and say, "Oh, well, there's no evidence for flat Earth. It's all biblical." Not for me.
Got it. And Team Skeptic, do you want to put your link in the chat for where people can go to do the after show?
Yeah. Well, Chris.
Yeah.
Yeah, I mean, Chris, I put his email in the text chat here. If you want to get that and email him, he'll get you a link. But yeah, I mean, I had a pretty fun time on this conversation tonight, and I hope that Chris will come back in the future.
Cool. All right. Thank you very much, as always, for you guys joining us. Once again, from the bottom of my heart, thank you for making a dream for me come true today, where we hit that number that I always wanted to hit. I can now retire, so Monday you will have a brand new host for this show. I will be in the live chat with you guys watching it in my retirement. And yeah, what a wild ride. What a wild ride. We'll have a look back. No, I'm just kidding. Tomorrow we'll have story time with me. We'll probably do that about let me ask the chat real quick before we close out. Should we do it before Game of Thrones or after? Do we want to be in that anticipation mode, or do we want to be pissed off when we do this? Let me know in the chat, and then we'll close out just a couple minutes. Because this is the only 2.0. I hate the lag that we can't.
Probably that.
What, Casey?
Casey wants to know, what do you say when you don't
got-
give a fuck about Game of Thrones?
What's the right
After.
answer when
You don't say anything.
After seems to be the one.
You don't say anything,
Actually-
Casey, because no one needs to
right
know.
in the middle, right in the middle
Who
of
doesn't
Game
like
of
Game of
Thrones.
Thrones?
Before,
Before, I see a lot of after.
after. Oh, it's
How can you
even.
not like Game of Thrones?
It's even.
If it's even, then
I think we'll have to do it. I think we'll do it. I think we'll do it after, because I think we're all going to need to vent, and we're all going to need to bitch and whine and complain and get our thoughts out about it. So let's say at 10:30 we'll have a little bit of a late night get together. I can tell you about the horrible experiences that I've had over the past 3 months. I'll give you the number. You can call in. We'll talk, and you can tell me about anything you want, and we'll just do a real chill us and you stream. Okay, so I'll see you after Game of Thrones. I would tell you who I think is going to sit on the throne, but I don't want to ruin anything for anybody that may have not been caught up yet. So I'll end with this. Dracarys.